Hello, my name is Ameer. I'm presenting the extension highway to connect row 12 to 43 project. So due to restriction of time, I'm going to start with the selected route and I come back to talk about the multiple design criteria if the time allow. So the selected route intersect at angle 89 and I'm going to start with the horizontal alignment for this route. Here is my typical assembly have this characteristic related to slope and length. It's over here, and then the highway really start with this assembly to station 850, and then that assembly become with the transition lane from 850 to 1330, and then the predominant assembly until station 34, and then this assembly over here all the way to the end of the alignment. Here I calculated the sub inside distance for the horizontal curve and the minimum radius. All right, and this is the layout of the horizontal alignment. This table shows the compliance with the minimum radius. There is the super elevation curve. All right, and this is a compliance on Civil 3D with the stub inside distance based on AASHTO principles. So now let me talk about the highway corridor. Here is my layout for the highway corridor. And in case if you're interested, this is a 3D view of the highway corridor. This is the surface. All right, and this is show the transition at the beginning of the highway at station 850 where the assembly change. This is show the transition where at the end of the highway close to the intersection. Let me talk about the vertical alignment next. So I did the K values for my vertical alignment consists of sag and one crest curve. And here is a K value for these. This is my profile. This table shows the compliance with the 7%, and this is a vertical geometry. And next we have the cross sections. This is cross section. We are really interested about the cut and fill. So at station 9 we begin by fill on the right, fill on the left. And then the cross section change to with terrain on the left, fill in the right. Then at station 11.75, cut on the left, fill on the right. Cut on both at station 13 plus 25. And then at station 25, it become cut and with terrain on the left. So this is we're gonna evaluate the longitudinal barrier needed based on this. The earthwork required over here, the volume of earthwork, this is a numerical value calculation based on Civil 3D, and this is my mass hole diagram for this. Let me now talk next about the design criteria. We're talking about the basic assumption, the type of the highway, and the ADT. Clear zone based on AASHTO. My speed limit, let me talk about my speed limit. It's going to be 40, and then it's going to change to 30 only at the horizontal curve, as shown. The cut slope is 2:1, and the fill slope is 4:1, so we only require barrier at the cut slope. And the placement is going to be along the shoulder, as shown. This is the length required along the left and right side. Here is the drawing of the barrier. It's going to be guardrail. We choose this because there is no safety concern. And this guardrail from station 25 until the end of the highway, it's in that station 33, as shown. All right, and here is I summarized the length where it's required. So next we have the signage design. Here I have all the consideration, the type of the signage we need and why or why not we need. So let me move to the layout. We can show where are the signage located. Here is speed limit signage, and this is warning for end of lane. I mean at the beginning of the highway, station 13. And then this is middle of the highway, speed signs all at the curves. And here is the intersection, the stop sign, the directional sign, and the only sign with the speed limit. All right, and then this next, let me talk about the intersection design. Here is the side triangle for the left turn case P1. It's shown over here. It's a green triangle, and then for the right turn, it's a yellow triangle. And all the values are shown on the tables. We consider the R turning of 51.2 for the SU SU40 vehicle where the inner radius become 39.2. Any extra radius for any extra distance for overhang it can be compensated by the lane width, since we are considering the inner radius from the first to the first lane, center of the first lane to the center of the first lane. So here is the layout of the intersection on Civil 3D, more close picture on the layout. And here is a 3D view. It shows how the intersection work. All right, and here I have the profile for the intersection, as you see, and the approaching grade is 2.04. All right, so if you guys have time, we can just talk quickly about the multiple design criteria. Let me move to over. And by the way, I choose the Word file for the reason I have a lot of information, so it's not gonna really fit in PowerPoint. All right, so let me show this table just if you guys. Just 1 second. All right, this is a table. This table show the values for all the selected routes. And again, this is the beginning. Let me show the routes very quick. This is the length of barrier. So we can just start from the beginning. Yeah, this is the layout, the basic design assumption. Route 1, the selected route, and the length intersect at station 89 as we said, and vertical alignment, compliance, predominant assembly, earthwork, and then route 2 over here. It's the same route with just different side slope. Intersect at the same angle, same vertical profile, compliance same, predominant assembly same, mass hall diagram same, numerical values. And then after route 3, it really has different horizontal alignment and intersect curve, where the intersection at 79 it does satisfy as shown. Vertical profile, only one side curve, compliance, predominant assembly, and over here mass hall diagram for the third route. Yeah, so over here we just quantify the criteria for the multiple design assumptions. Barrier length on route 1, this is a station we need based on the slope we selected, and we're not gonna need barriers on route 2, we're gonna need barriers on route 3. The objective of the design criteria, length of barrier, minimize cut and fill as shown, and here is the table. All right, and over here you can guys see the sum. We had the option to choose route 1 or 2, but for engineering judgment, based on my engineering judgment, I selected route 1. Thank you for listening, and we hope you guys enjoyed the presentation. Thank you.